Dear students, let us start with the next section, which is parallelogram, law of vector addition and subtraction. Now, about parallelogram law of vector addition, it is more or less like combination of our two triangular vectors. Now, to understand that carefully, let us draw a parallelogram. Now, we have a parallelogram that is drawn, as you can see, in which we can take the first vector, like what I have explained, as a vector A. That is, this is vector A that is moving in this direction. Meet me, nice. Fine. So this is A, vector A, in that direction, and we know it's definitely going to move in the direction that is what? That is always positive towards x-axis. Now, we have vector B. This is vector B. Vector B is now moving in this direction. This is B vector. And it's having an angle of theta, as usual, to the positive x-axis, which I'm going to explain here. This is the second vector. You can see it is more like our triangular vector. And from your mathematics knowledge, this angle is equal to this angle. Remember that. So corresponding angles are equal. So as the two vectors are moving, so we say, so that this side is parallel to this side, we can also call this particular side B vector, if we like. So now, what we do about the law, before we now complete it, it is like completing what? The two sides of the triangle, which are two different diagonals, which we can trace out in this parallelogram. So what we say in the parallelogram law of vector, a quick one, my dear student, is that to add two vectors, and just quickly write that, I will use abbreviation to add two vectors. We place both vectors at a common point. As you can see here, my dear student, what I've done here is that this is the first vector, this is the second vector, this is their common point. So by placing it together to at a common point and complete the what? We complete the, then complete, or let me just write a good English. Okay. And complete the parallelogram. To complete the parallelogram by joining the two adjacent sides of parallelogram. So the diagonals, because there are two diagonals in your parallelogram, the diagonals between these two vectors diagonal between these two vectors gives the addition and subtraction. So this we call the parallelogram law of vector addition and subtraction. So I have only drawn out a good diagram of what? Of a parallelogram in which I want to show you a rough sketch. You remember pictorial from our clean this just for you to see the way I form my parallelogram for understanding. So I have this, that is the first vector. Then I am joining it with the second vector, which is, this is vector A, remember that. And this is vector B, which is always going to have angle towards the positive x-axis. I just wanted to see how I come about my parallelogram. Now, what we do in physics is we have the first one, then we join the direction, this is B. We now join this one in this format. As you can see, my dear student, we form something like this. Diagram goes down to scale. or basically because it is going like that, let me make it like this for you to see. So this is the B vector, is having an angle or a direction of theta towards the positive x-axis, which we discussed. So this is A and this is B. So we now complete the two adjacent sides. This is going up. We complete this side also by going up. So what we do next is now we are now complete this by joining this side to this side. Then we have completed our parallelogram. This is the basis. You can see this is A, this is B vector, this is also B vector. So inside the what? Inside the parallelogram, we now join the what? We join the what? The longer diagonal. If we join this longer diagonal, my dear students, we have the C vector. And you can see C vector is the sum of A vector and what? And the B vector, which is the same thing like our triangular law. So that is why we say the C vector here give us the A vector plus the B vector. I hope you can visualize. But if we draw the other diagonal, which is the short diagonal, let me call that one the D vector. You can see D vector is more or less like what? You can see the A vector minus the B vector. You can ask me how. It is very simple to see if you can work. Look at this A vector. A vector. A vector is like the resultant of this vector and this vector. See, this particular vector and the other vector here. This vector going like this, the other vector which is going like this, then this is the resultant that is balancing. So we can say A vector plus D vector is equals to what? B vector. That is the other diagonal. So here we see D vector is equals to A vector, B vector minus A vector. You can just go like that, and it's always acceptable. So what I'm doing here is just for you to quickly see it. I am going to clean it as promised for us to have a better diagram to understand. I have only shown that for us to get what I want to put here. So because we have to prove the formula, we use a parallelogram of vector, and why we add the first one and subtract the second diagonal. Mostly in your syllabus, my dear students, you are only asked to know the parallelogram of vector addition. I only try to show you that the other diagonal will give you the negative of the vector, and in that case, you are going to have negative of B because B is acting in opposite direction when we visualize. So now here from here, to have a good diagram, we draw the diagonal of the vector of that, and by doing that, let's use a broken line. So here, this is the first one, which is the long diagonal, which I want all students to see. As you can see. So this particular one, I told you, my dear student, that this is also parallel, and that is prepared. So this particular one that we use to watch, the line adjoining these two is called the diagonal, and this is the resultant vector, which we call the C vector. Remember, C vector will always have a magnitude of what? A direction of an angle, which I will call what? Alpha. I hope you can see. Just like our triangular vector that we have discussed in our previous class. So here we can say C vector here is the sum of A vector plus B vector, which is what? The same thing as representing vector pictorial. So that is how we come about that. And to further what? Bring out the formula we use for parallelogram of vector and how we solve what? Questions on this. We can try and complete this diagram and see what I am talking about. To do that, let me quickly do that in this other side of the book. Now, about that quickly, we can say we have, let's say we have parallelogram. Let's make it a little bit quick. So we have it in this slide. For understanding sake, I want to bring out something. Then we have I'm only showing vector addition. I told you if I go by the other diagonal, it will be the subtraction of A vector minus B vector. Now, but we are not talking about that because it is not in your syllabus. But if you want to know that, you can as well follow the same steps and follow to do the addition. Now, if I down one directly, we can also say, my dear student, I hope you are not being bored. Now, from here, we go by this and complete just like what we have here. I'm just trying to show it in a neater version for everybody to see. So from here, we can see here, remember the total angle, this is A vector. These are the B vectors, which are parallel. This is the resultant vector, which is the C vector. Remember that I will say C is equals to A plus B. So the A vector is moving in this part. The B vector is having magnitude of B and the direction of theta. Remember that. Then the C vector, which is from here to this point, is also having its direction towards, let us be careful, as theta is ranging from here to here, as you can see from here. Now, whereas the other one, which is the C, is having its own angle as, let me do something a little bit different for understanding sake. So here we have this is this, and this is theta. So whereas the C vector, which is the resultant vector, is having its own angle or its own direction to also towards the positive axis, which I take as alpha. Hopefully I can see that very clearly. Now to complete this, and actually to have what we call the rectangular component of vector, I will try and extend this line. My dear student, I want you to follow through. And I've extended this line with, we are going to have something like this. And the question is, why am I doing that? Because I want to try as much as to bring another particular or perpendicular line in such a way that is going to balance this one. And that is what I'm trying to do in my next one. So let me try and do that very well, because I want this to be straight, even though diagram is not drawn to scale. So what I'm trying to do here now is like trying to bring a perpendicular line that will be what? Perpendicular to these two. So if we have this, now let's try and bring, actually I've slanted this one, and I'd love to use my own diagram, which will slant it in a way in which I want. But if I use my diagram for you to see, it will not be that smooth, but I think it's better. Now quickly look at this. If we have this, oh, that is too bad, excuse me. Then let me do something. Okay, I think it will be better like this. Then we take this one like this. Just the same diagram, but I just want it to be straight. Take the other one like this too. We join this to this. I'm still doing the same thing. Just want everything to be neat. So we bring out the resultant vector addition, which is that. Then I'm trying to bring out a perpendicular line because I want you to see it clearly. It will not work well. So that I'm going to have something like a rectangular component of A and B. And I think it's working like this. And I try to balance this again. Remember, this is A. These are B vectors. And this is the resultant vector C. Please, all diagrams here are the same thing. And we said P is having an angle of theta. The direction is always towards, and C is having the resultant of alpha. The resultant one is alpha, like what we have done in our previous slide. A quick one, to complete this one, we extend this as usual. And like I said, if here to here is theta, the same thing that is applicable here, here to here is also theta. And remember, here to here will be 180 minus theta, as we have already discussed under our triangular curve. So what I'm just trying to show you guys here is that this line I have brought here, which if I try to do that, it won't be straight. That is why I go for a slant beta parallelogram. So dear students, from here we can now say, looking at it directly, you can say, so far this is a perpendicular line. This is at 90 degrees. We can call this one rectangular component of what? Of this for A and B. Then doing that rectangularly, I told you the other time, this side is what? The B sine theta from Pythagoras theorem, and this side would be what? B cos theta. So we direct you want to get the formula, which is what we want to talk about here. So we can say from Pythagoras, look at the triangle I'm looking at. This triangle A, let me just give it A, B, and C. I just want you guys to see it clearly. Now I can now say from Pythagoras theorem. From Pythagoras, I'll be fast because the time allotted for this is almost over. From Pythagoras, I can say C squared is equals to, I'm taking the whole triangle now. We say C squared is equals to A plus, because distance from here to here is A plus B plus theta. So A plus B cos theta all square, then plus here is B sin theta all square. Expanding this, my dear students, remember, just recall that from your trick, sine squared theta plus cos squared theta is equals to 1. So expanding this one from our algebra class, we are going to have C squared is equals to A squared plus B squared plus 2AB cos theta, which is what we are going. And this particular law is called what? It is more or less like a cosine rule, we still remember. And this we use to calculate the magnitude of the resultant vector C, which you can write C as the square root of this. Always keep that in mind. Then about the direction, I don't want you to waste time. I don't want to waste time. About the direction, just like what we have done in the triangle law of vector, we say we use what? We just go by what? The same. You can see that this is what? A right angle triangle, my dear student. So from that, I'm just going to say opposite over adjacent. Remember that. So we say tan alpha is equals to the opposite there is the B sin theta, and the adjacent there is what? A plus B cos theta. So directly we say alpha, which is the direction of the resultant of the parallelogram law of addition, we just do tan inverse of B sin theta over A plus B plus theta. This formula you also need to keep in mind, because I've told you whenever I mark the formula, we are going to use it when we start work example. You just need to keep this formula at the back of your. So a quick one which I can also quickly talk about for a direct formula in case you have equal magnitude. So if we talk about equal magnitude, so we can also quickly talk about that here in no time. I have 2 minutes more. Vector addition of equal magnitude. Now, when the magnitude of the vector are equal, now let's say here now, instead of this now, this is B, or let's take everything, this is A, this is also A, this is A, like A and A vector are giving you the resultant vector C, which I will use R here. Using this for the equal magnitude diagram, a quick one. Now, from what we have just studied here, using the same formula which we have here, directly you can see both of them are now A. So I can put that like saying C squared is now equals to, you can see A squared plus A squared, or let me just say C directly. I don't want to waste time. It's now equals to square root of, I'm taking it directly from here, A squared plus A squared plus 2A squared. Where I see B here, I'm putting A. My dear students, time is not on my side, but we can also do that, cos theta. So directly here, from your mathematics knowledge, we can say, now we say the resultant vector, which is C, or I use out here, anyhow, will now be equals to, I'm factoring out A outside under root of, this is will be, give me 2 plus 2, that's 2A squared plus 2A squared, which you understand, 2 plus 2 is cos theta. So directly I can say here is the same thing as another way of factorizing, for a quick one, R will be equals to, we have A outside, then I'm going to have 2 square root of 2 open brackets, excuse me, 1 plus cos theta. All these are derivations because of your exam. That is why I'm trying to show all this steps. But what you need in calculation is just the final result. So directly we can say, since from your trigonometry, you know that 1 plus cos theta, I can show you that, is equals to 2 cos what? 2 cos squared theta divided by 2. So keep this in mind. If you are seeing this for the first time, you can watch my full course trick video online to understand all this stuff. So here from here, substituting that in this formula directly to the final one, once the R is now equals to 2A, because I'm putting this value, guys, cos theta by 2. So this particular formula and magnet is very important whenever you are having two equal magnitude and you want to use cosine rule to get the resultant, the magnitude of the resultant. So please always keep that in mind. Cosine rule or what you call parallelogram law of vector are more or less the same thing, but the derivation are quite different, but the application might be the same. So in the next slide, we are going to talk more about examples and some calculation as regards what we learn. See you soon. Bye for now.